Stop building AI agents that depend on 5 different APIs just to say hello. If you are building real-time voice AI, latency is the enemy. A 2-second pause doesn't sound like thinking, it sounds like a broken connection. I've built a solution that runs entirely on DigitalOcean, and a huge thank you to Hyder from their support team for granting me access to this beast, the Nvidia H100. By the way, if you want to try this yourself, you can grab $200 in free credits on DigitalOcean via the link below. But before we build it, let me show you what true sub-second latency actually sounds like. Let's run the demo.
How to place a microphone.
To place a microphone, position it 2-3 inches from the speaker's mouth or instrument. Just angle for optimal sound quality and minimize background noise.
How do I exchange cables of my headset?
To exchange cables on your headset, locate the screws that hold the cable compartment in place and remove them. Carefully pull out the old cable and insert the new one into the corresponding slot. Reattach the screws to secure the compartment.
How can I maintain the cable on my headset microphone?
To maintain the cable on your headset microphone, gently pull the boom away from the cable hanger and replace if damaged. Regularly clean the windscreens to protect against wind and pop noise.
Now we're building the holy grail of AI infrastructure, a sovereign voice agent. We are cutting out OpenAI. We are cutting out the network lag. We're running the brain, the memory, and the logic, all on one massive DigitalOcean H100 GPU server. I'm going to show you how we achieved sub-second latency, under 700 milliseconds, by orchestrating n8n locally, using Supabase for vector storage, and running Llama 3.2 directly on our own hardware. No per token fees, total data privacy. This is the infrastructure. First, let's talk about the hardware. Most people run their logic in Europe and their AI in the US. That Atlantic ping-pong kills your voice demo. We need a super server, one machine but does it all. We chose DigitalOcean's H100 GPU Droplet. Why? Because LLMs live in VRAM. We are using an 80 gigabyte H100, which is overkill for a small model, but it gives us the headroom to run n8n, our Supabase database, and the Llama inference engine all on the same localhost network. Zero network latency between the brain and the body. We deployed this using a custom Docker stack in the NYC2 region. A critical tip for DigitalOcean users, these GPUs are expensive, $3 an hour. I'll show you at the end of the video how to use snapshots to freeze your billing when you aren't working, so you don't burn your budget. We aren't using GPT-4 here. It's too slow and too expensive for a voice agent. We are running a Llama directly on the GPU. We chose Llama 3.2 3B. It's the perfect edge model, smart enough to follow instructions but small enough to respond in milliseconds. Look at these logs. When we used an external API, embedding text took over 500 milliseconds. By running nomic embed text locally on the H100, we dropped that to 18 milliseconds. That is the power of sovereignty. A pro tip for Llama. By default, it unloads the model after 5 minutes to save RAM. This causes a cold start delay of 3 seconds on the first call. We fix this by setting the Llama Keep Alive environment variable to 24 hours. Now, the model is always hot and ready to talk. For our agent to actually know things, like reading a technical manual, we need RAG, Retrieval Augmented Generation. We are self-hosting Supabase via Docker right alongside n8n. Here is a common trap. We switched our embedding model to MXBAI Embed Large, which uses 1024 dimensions. If your Supabase table is set to the default 1536 OpenAI standard, it will break. We had to recreate our table structure to match the local model. We push data into Supabase using a separate n8n ingestion workflow. It takes a PDF, chunks it into small 500-character segments, optimized for voice reading, converts them to vectors using the GPU, and stores them locally. No data ever leaves our server. This is the heartbeat of the system, n8n. Because we are self-hosting n8n on the same Docker network, it talks to Supabase and Llama over http://host.docker.internal. The most important part of a voice agent is the system prompt. You cannot let the LLM ramble. We instructed our agent to be extremely concise. Limit your response to maximum 25 words. Speak conversationally and warmly, but get straight to the point. Strictly rely on the tool content. If the answer is not in the tool, ask the user to clarify. Output plain text only. Do not use asterisks, lists, emojis, or markdown. In the Supabase node, we added a specific tool description. If you leave this empty, the agent won't know when to check the manual. We explicitly told it, use this tool for warranty, specs, and cleaning instructions. Now it has 100% hit rate on retrieval. This system is powerful, but an H100 costs money. If you're a developer, do not just power off the droplet. DigitalOcean will still charge you for the reservation. The secret is to take a snapshot and then destroy the droplet. When you need to demo again, restore from the snapshot. It takes 5 minutes and saves you thousands. We successfully built a sovereign AI. No OpenAI, no latency, full privacy. Well, almost full. There is still Twilio for communication and Deepgram for text-to-speech and speech-to-text. If you want the n8n workflow templates, check the link in the description. Go build something fast.